Alrighty, we're going to talk about aerodynamics in this lesson. So let's get to it. This is going to be divided into three parts, 8.1, 8.2, and 8.3. And so you'll want to make sure you have the note packets ready to fill out these notes as we go along here. So let's start with some basics here. We're talking about the four forces of flight. And since we're talking about aerodynamics, let's define aerodynamics. Aerodynamics is the study of air and the forces it has on bodies moving relative to that air. And we're going to learn about four forces of flight, how lift is created, parts of the wing, different types of drag, things like that. So we're going to start with the four forces of flight. There's four of them. There's lift, weight, thrust, and drag. And you're going to want to memorize those four. So one fact that the FAA seems to want you to know all the time is the forces of lift, thrust, gravity, and drag are all equal when the aircraft is in unaccelerated, straight and level flight. Unaccelerated, straight and level flight. So what that means, sorry, I had to grab my model here. So what that means is when the aircraft is just cruising along, it's not accelerating, it's not slowing down, it's not climbing, and it's not descending. When it's just cruising along, all those four forces are in perfect balance, so to speak, even though the plane's moving forward. And some people are like, well, doesn't thrust have to be, equal to that? Well, maybe, but think about if you were in outer space and this was just floating and you just lightly pushed on it, it would start moving forward. It's kind of like what we call like a glide or a cruise or something like that. So we want to make sure that we understand that when it's an unaccelerated straight and level flight, they like to ask questions on that on the written test and things like that. So you just want to memorize that statement there. So let's talk about lift to begin with. So there was this Swiss mathematician named Bernoulli, and one of the principles that he had said when velocity of a fluid or an air is increased, its pressure decreases. So how does that help a wing produce lift? So let's take a look at this wing here. So over here on this side, you'll see here that there is air coming over, and it's going over the wing, and it's also coming under the wing at the same time. Notice that this wing is curved. So in order to not create a vacuum above the wing, because nature abhors the vacuum, this air needs to accelerate in order to meet the associated air underneath it. So this air is going further, so it's got to go faster. So that creates low pressure up here, because it says when the speed of a fluid or air is increased, the pressure decreases. So that means that the pressure is lower on top of the wing than on the upper part. So since this is going faster and this is going slower, there's less pressure up here and there's more pressure pushing up, which causes this wing to go forward in the air, go upwards, I should say, into the air. Alrighty, so here's some terms we want you to know. This is what we call an airfoil. An airfoil is basically another name for a wing. A foil, like, is a type of sword that cuts through something. So an airfoil is something that's cutting through the air. So let's go over these parts and terms that we're going to use when we talk about airfoils. The first one is the leading edge. That's the big front of the airfoil. And then the back is the trailing edge. Then we have what's called the chord line. The chord line is the imaginary line from the leading edge to the trailing edge. So even though this purple line, we can see it, if you looked at an actual wing, they don't actually usually paint that on the wing. The type of curvature the upper wing has is called the upper camber. Upper camber. And that means that this down here is the lower camber. Now these next three terms are ones that we're going to talk about quite a bit in depth. The first one is the airplane path. That's the direction the airplane is flying through the air. Then we have directly opposite the airplane path is the relative wind. And the difference between the chord line and the relative wind, so the red line and the purple line here, the relative wind is the red line, the chord line is the purple line, is called the angle of attack. So to put that more simply with our little model here, the airplane is moving forward. That's its flight path. Even if it's pitched up like this but moving like this, its flight path is that way, which means the relative wind is this way. Now, if it's going upwards like that, then its flight path is that direction, and the relative wind is coming at it like this. So you always have to know where the airplane's flight path is in order to understand where the relative wind is coming from. So here's some definitions. Chord line, imaginary line between the leading edge and the trailing edge. Angle of attack. This is the angle between the relative wind and the chord line. It's one factor that determines the amount of lift generated by a wing. So here's some different images of angles of attack. We'll go over those in class. The camber is the characteristic curvature of the wing. Different camber for different types of operations. So we'll talk about more of this in class, but if you have a kind of big, fat kind of wing like this, that's meant for gliding. That's meant to generate a lot of lift, but it also creates a lot of drag. If you have something like a high-speed airfoil, you'll see that it's very different. These are both types of wings, but they're just used for different operations. One of the things we talk a lot about with private pilot training is something called stalls. Stalls are caused by the separation of airflow from the wing's upper surface. Here's 3 things you should know about stalls. Number 1, a stall causes a rapid decrease in lift. For a given airplane, the stall will always happen at the same angle. Different airplanes, different angles. We're talking about the angle of attack here. That angle is called the critical angle of attack, where it will always stall. And this is the difference between the relative wind and the chord line. We've already talked about that a little bit. We're going to go into this in depth in class. There's a real quick review of the 4 forces. And what was the answer to this question? An accelerated straight and level flight. We're going to go review these again. And we're talking about stalls again. Watch a video about stalls. All right, now let's get into some more talk about stalls here. 6 types of stalls. Number 1, an approach to landing stall or a power off stall. We'll talk about that in class. Departure stall or power on stall. We'll talk about that maneuver in class. Elevator trim stall. Too much nose up trim. Cross control stall or a skidding turn stall. We'll talk about that one a little bit as well. And then finally, the last 2 are accelerated stalls. This is when you actually stall above what's called the stall speed, usually in some kind of turn where you increase what's something called load factor. And we're going to talk about load factor in this lesson 8 a little bit later. We get to weight. An accelerated stall, well, typically the stall speed is going to be right about down here, either at the bottom of the green arc or the bottom of the white arc, depending on our configuration, flaps in or flaps out. And if it's accelerated, it's basically happening somewhere up here in the arc. It's happening above that stall, what should be the stall speed. And we're talking about why that is later. And the secondary stall, you stall and then you stall again right away. So we're going to talk about all those stalls more in depth in class. So don't worry about them right now. Just kind of get them written down in your notes. So when we're talking about it, you can focus on what we're talking about. How do you recover from stalls? Well, if the problem is, if the plane has reached a critical angle of attack and it's stalling, you just want to lessen that angle of attack. So really, in most cases, you're just going to lower the nose. You're going to lower the nose when you are recovering from that stall. So you just return the aircraft back to a lower angle of attack. Remember, center the ball when you stall. We'll talk about that later, but if you don't have it coordinated, you could put the plane into something called a spin when you stall it. You can recognize a stall by slowing airspeed, buffeting. The wing will start to shake a little bit. The stall horn is going off when a stall is imminent. Nose dropping, sudden loss of altitude. The stall recovery is lower the nose, release the back pressure, level the wings, center the ball, and add power if you don't have power already in. We'll demonstrate these on the simulator in class. And that's the end of lesson 8.1. So make sure those notes are filled out and be ready for class.